Okay, hello people. Um, yeah, this is gonna be a video about me learning threads in C++. I will try to follow a book, concurrence in action, and I will try to implement some basics like creating threads, running something on the separate thread, and yeah, I have roughly like 30 or 40 minutes, and I will try to learn as much as I can during this time. Yeah, so you can follow along with me if you're interested, but let's get started. Okay, I will be using Visual Studio this time because it's much more easy. It has like autocomplete for, and for C++ it's much more convenient for me. I was playing around with DirectX, so yeah, forgive me please if you see a lot of tabs. But I will start from here, from the getting started section, and I will try to actually follow the whole book because I really need to learn like about threading in C++ and how it works, and how to use std thread and how to manage them, how to create pools of threads, how to assign different tasks to threads, and etc. So what I want is I will probably create like a separate playlist with me learning about threads, and it will be like videos 20-30 minutes, not more than that, where I'm trying to follow the book. The book itself doesn't contain any exercises, so your own exercise is just like how creative you are, basically how far you can get with the knowledge provided by the book, experimenting on your own. But yeah, let's get started. Okay. Okay, so then that's like the main. Okay, so first of all, we have to start with including the file like thread. And I hope like everyone is familiar with basic idea behind threading. But if you are not, I highly encourage you to start reading from the beginning of the book and kind of one step at a time. It will help a lot. But for me personally, like I do understand more with practice, so that's why I just started typing the code right ahead. And what I will do is I will try to create a thread, and my first thread, and so that's what we do, and let's run the program. And it succeeded. Do I need to? Probably I do. Okay. So I have created a thread, and yeah. Okay, let's see. The first difference is the extra include thread. Multi-threading support in the C++ library. I in a new header. Okay. Okay. Has a new function hello. So basically the hello is the function that will be executed on a separate thread. But what I want to do right now is just take a look at the window, at the threads window. And whenever we create a new thread, okay, so we don't. Oh, so maybe actually we create an instance of the std thread function, but we don't actually execute any threads, because maybe we have to provide something. Okay. And that's really annoying for me. What I usually do is That would be fine. What are you complaining about, Mr. Compiler? Oh, obviously. Executing on a separate thread. So I just want to print the string and let's pass the function itself. And that's not actually a function call. And let's compile and see what we have. So as you can see, yeah, it's pretty tiny. I should probably have increase the font size, but okay, so I still don't have any threads and I don't see anything. Yes, but at least I have an assertion, and this basically says me that it printed the string in my case, but it says that aborted the program. And it, as you can see, it comes from thread constructor, which basically throws an exception. It doesn't throw an exception, but it terminates, right? And it checks whether the thread is joinable. If it is not, then it terminates. And in our situation for the program to end successfully, what we'll have to add is join method. So basically, I will explain in a second. There are, okay, yes, and now everything works fine. Yeah, but what we're doing here is we're creating a thread, we running like this function on a separate thread, and by saying this, by calling this join procedure, what we are doing is we're saying, okay, wait until the thread finishes its execution and then continue executing the main thread. So for example, if you have had, like, let's include Windows.h procedure, and for example sleep for 3 seconds, and print something. Thread has finished its execution, and I will put a breakpoint and let's see what happens. So basically we are not hitting the breakpoint, and now we hit, because basically we are saying by join that let's wait for 3 seconds until this thread finishes, and then continue all the tasks that we have, like all the code, executing all the code that we have in the main thread. But I will not be using that. And you might ask, what is the reason then to create a separate thread if we are waiting for it? And that's a question that I don't have an answer for. Yeah, that's why I want to study, is because my knowledge about threads is pretty bad. Let's continue. Has a new function. Hello. Okay. To wait for the thread associated with the thread object, in this case T. Okay, so that's fine. That's fine. Every C++ program has at least one thread, which is started by the C++ runtime. The thread running main your program can then launch additional threads that have another function as an entry point. These threads then run concurrently with each other and with the initial thread, just as the program exits when the program returns from main. When the specified entry point function returned, the thread exits. As you'll see, if you have as the thread object for a thread, you can wait for it to finish, but first you have to start it. So let's take a look. Okay, into launch. So here the author implements like a class and overloads and specifies the basically call operator, right? I will go with struct because background task. And what we have to do is we can overload this operator and out. Okay, so that should be fine. That should be fine. We can remove that function completely. And then what we can do is create an instance of background task, and then provide it to the thread itself. And let's see what happens. Okay. So as you can see, we receive the string in the console output performing task on the background, which is exactly what we want. And we can even provide like some arguments. Let's just specify the simplest possible. Is that correct? I think so. Okay. Because this is defined in the std_int. So in order for that declaration to be visible, I have to include. I should have included that file. Argument. Okay. Parameter 0, and we'll try to display. But right now that's a problem. That's a bit of a problem, right? That's a bit of a problem. Well, I can do it directly. No, error condition is not what we want. Parameter 0, and we print out the parameter. And in order for us to put the parameter, let's see what happens, and I will explain in a second. So as you can see, we have printed everything successfully, and it's what it does actually. It copies the value because every single thread has its internal stack, right? And it doesn't use the value from the main stack. It just copies whatever we specify. It copies the value on its internal stack, which belongs to my first thread, and then it passes to the function from its internal stack rather than from the stack which belongs to the main thread. And that's how that's actually how it works. And we will encounter some issues with this because, for example, we cannot pass a reference, but actually we can, but we have to find a workaround. So we can use, for example, std_ref, which wraps a reference, and then you can pass it. But if you're trying to pass a default reference, it will not work because it just copies the contents. But let's continue. That's not what I want. Okay. Okay, so in order to start the thread, you have to construct a std_thread object that specifies the task to run on the thread. In the simplest case, the task is just a plain ordinary void return function that takes no parameters. This function runs on its own thread until it returns, and then the thread stops. At the other extreme, the task could be a function object that takes additional. That's what we have in our case, like that's the function object. We could have specified exactly the same, but just a regular function, and it will be completely fine. Right. And then the thread stops. At the other extreme, the task, specified through some kind of a messaging system while it's running, and the thread stops only when it's signaled to do so. Again, via some command of messaging system. It doesn't matter what the thread is going to do or where it's launched from, but starting a thread using the C++ thread library always boils down to constructing a std_thread object. And that's exactly what we did. You have to make sure that the thread header is included. In this case, the supplied function object is copied into the storage belonging to the newly created thread. And 5 are copied to the internal storage of the newly created thread, which is correct, right? Behave equivalently to the original, or the result may not be what's expected. When passing a function object to the thread constructor is to avoid what is dubbed C++ most vexing parse. So it's basically when we define the function, declare the function rather than creating a thread. If you pass a temporary rather than the named variable, okay, I didn't know about it. And let's actually use scopes so it's easier to structure the code. Like it improves the visibility a bit. So I specified the thread, and what I would do is I will grab the structure like this. I will create an instance, and we can even define the constructor, but the constructor is self-defined by default. Let's maybe specify some variable. And then we don't need to pass anything. Okay, so what's happening? Let's do this, and let's do this. Okay, and let's print the value of the member. So that's fine. That's fine. We don't have an overloaded constructor, so we have to specify this. Oh, we technically could. Let's do that. Let's specify 12. And if I understood correctly, what the author is saying is that it's like a function declaration. C reference. Okay. I delete it. Okay. So we had an assertion. and that become because if you take a look at the debug Windows call stack exe main, and it happened here. When we went out of scope, so basically I don't still understand, either it's like a thread creation or it's just a declaration of a function which is called myThread, which takes the instance of the background task and then it returns an std thread, but we are not calling, we just declaring the function itself. So let's see. Then the syntax can be the same as that of a function declaration, in which case the compiler interprets it as such rather than the object definition. For example, declares a function myThread that takes a single parameter of type pointer to a function. Yes, no parameters, and return background task object. Okay, so it's basically like this. So that would be the function pointer in this case. And for people who don't understand, it just so myThread is a function pointer which takes a parameter of type background task and returns std thread. So basically, in theory, if we could have like the function, what we can do is we can take like myThread, we can create a function, it's not a void, it's thread, What we could do is we could assign myThread equals foo and then myThread call background task. So that will be completely reasonable, but I just want to show you what's happening here so you don't get confused. But that's not the point of the video. Let's continue starting about threads. Okay, so we can surround it with in the first example, the extra parentheses prevent interpretation at a function declaration, thus allowing myThread to be declared as a variable of type std thread. The second example uses a new uniform initialization syntax with braces, threads, and parentheses, and thus would also declare a variable. Yeah, you can use a lambda expression, which calls basically a couple of functions. Once you have started your thread, you need to explicitly decide whether to wait for it or for it to finish by joining with it, or leave it run on its own by detaching the thread. Another thing that we could do, we could do this. Leave the thread running. Just created a random function. I don't want to like spend a lot of time writing actual functions. For now, I just want to see how it behaves when we either join the thread or when we detach the thread. What the difference, like when we hit assertions, etc. So what we can do is we obviously have to provide leave the thread running, and what we have to do is specify my thread detach. Yeah, so basically what it says is don't wait for the thread to finish, right? And for example, remember we've talked previously about this slip function. I already removed the header. So let's sleep for 3 seconds, but you will see that we will not be waiting for it. I will put like a debug break here to make sure that we hit a breakpoint once we get to this line. And we actually do that pretty quickly because we will not be waiting for this thread to finish. We just detach it, so it will be executed. It will continue the execution on the background, and but we will continue the execution of the main thread. And we hit a breakpoint, and it was quite soonish, right? It was still running, but yeah. So let's see what else do we have. If you don't decide before the std thread object is destroyed, then your program is terminated. And that's exactly what happened for the first time when we didn't call neither join nor detach. Then your program is terminated. The std thread destructor calls std terminate. It's therefore imperative that very important that you ensure that the thread is correctly joined or detached, even in the presence of exceptions. Note that you only have to make this decision before the std thread object is destroyed. The thread itself may well have finished long before you join with it or detached it. And if you detach it, then the thread may continue running long after the std thread object is destroyed. Okay. If you don't wait for a thread to finish, then you need to ensure that the data accessed by the thread is valid until the thread has finished with it. Oh, makes sense. Makes sense. So for example, if you provide a reference if you pass a reference to the variable which is created inside the scope, and we use like the variable itself inside the function which is executed on the thread, and then we get out of the scope, the thread will be still running on the background and will be operating on that variable. But even though the variable itself was popped from the stack, right? That's wrong. Hasn't finished when the function exits. The following listing shows an example of just such scenario. The function that returns while the thread still has access to the local variables. So what we do is we create a local variable and we pass it as a reference. And we detach the thread, which means we don't want for the thread to finish. So yeah, here it might be still running, and I will not be creating a function. What I will do is I will create a scope. I will create a scope and struct foo. What we can do, well, it cannot be static. Well, it can. Okay. Operate on full. Okay. Update some data. Right. So that's what we can do. You will see in a second what I'm getting to, what I'm leaning towards. And let's specify some member. I don't know, some people prefer putting like an M prefix before the variable to highlight or to indicate that it's actually a member, instead of when we have a lot of like parameters, param0 and param1, etc, etc, etc. Usually we now have a way of distinguishing between Betazov's parameters came from like the function parameter list, or it's a member. But I don't do that, but for convenience, maybe. Okay. Yeah, and basically it eliminates the problem when you have to put an underscore, so you don't have name collisions. Okay, and what I can do, update some data. How do I specify the for loop? Cool. So that's the for loop index lengths. I can specify like the lengths as 1 shift 10. Which is exactly what we correct. And what we can do, just, I don't know, I'm writing out of my head some kind of code equals index. So we're basically updating the index, right? And we can even, no, I will not make it static. I will not make it static. Because we'll have to pass this pointer if you want to create a thread. But let me think. Okay. Some local variable equals 0, and what we'll do is we'll try to create a thread. So basically we have my thread here. And what we want to do is to pass, okay, we want to call the detach, the detach, and we have to specify something to the thread as an argument, which would be let me think. It will be a reference, and I will create an object foo, and I will pass some local variable, and then I will try to call the function foo update data. So that's the function, and the first, okay, I will make an error first so you can see what happens, because the first parameter, which is the first implicit parameter, would be this, right? So we'll see what happens. And what it says is that error foo update some data, non-standard syntax. Okay, to create a pointer member, so probably that's not what I wanted. We have to specify that. No matching overloaded function found is because we are not passing this pointer to the function, to the thread itself. What we have to do instead is we have to pass like foo, and again, okay, I can make it even more explicit, like foo pointer equals foo and foo pointer. And now it should be fine. Since we're iterating here, maybe I can increase the number, and let me quickly show you. So for example, 32, can I clear? No. That's this number, which is not that big. We can multiply it by 2, should be fine. So what do we have here is we create a thread, we execute this function, and we detach the thread, meaning that we are not waiting for the thread. And by the time we get out of scope, okay, so when we get out of scope, the thread will still be running, and it will be operating on this local variable, since we passed a reference here and we have a reference member. We can technically take a look at the value, but I'm not sure whether it will be correct. Let's see, some local variable. Yeah, okay. That's exactly what I'm talking about. It printed that some local variable equals to 0, but if we join the thread, if we don't detach it, we wait until the thread finishes its execution, so the variable will be updated. And if we take a look at this, it's exactly the value that we wanted, which is 32,768 multiplied by 2, which is exactly this number minus 1, because it's less than. So that's fine. But with the detach, we have we assert because the variable went out of scope already. Okay. But let's specify, I will remove this for now. In this case, a new thread associated with my thread will probably still be running when oops exits. Basically this function, right? Because you have explicitly decided not to wait for it by calling detach, if the thread is still running, then the next call to do something will access an already destroyed variable. This is just like normal single-threaded code, allowing a pointer or a reference to a local variable to persist beyond the function exit is never a good idea, but it's easier to make the mistake with multi-threaded code because it isn't necessarily immediately apparent. Okay, one common way to handle it, make the thread function self-contained copy, and that's totally reasonable. If you need to wait for a thread to complete, you can do this by calling join on the associated thread instance. Let me take a look at the time, 40 minutes. Yeah, we can continue. Detach before the closing brace of the function body, and that will work. I showed you like recently. Either you wait for a thread to finish or you don't. If you need more fine-grained control over waiting for a thread, such as to check whether a thread is finished or to wait only a certain period of time, then you have to use alternative mechanisms such as condition variables and futures. Okay, we'll take a look at the chapter 4. The act of calling join also cleans up any storage associated with a thread. So if the std thread object is no longer associated with a now finished thread, it isn't associated with any thread. Okay, this means that you can call join only once for a given thread. We can try that. We can definitely try that. Okay, so what we'll try to do is update variable. We create a lambda function and we'll do this. And I think I want to pass a reference to the lambda function as well. Maybe it can be something more complex than just a variable. We can bundle. Okay. String. No, that doesn't make any sense to me. Let's pass the string, and what I will have to do is it's maybe specified as a constant. Now, I just okay. So what I want to do is to write like to use as printf function and specify like the buffer and str string c string, and that's exactly what I want to do. But that's fine. We can leave it out it and just do it here directly. String and std handle. So that's completely fine. Then we can pass this and okay, so what we can do now is we can wait for the thread to finish, by calling the join procedure. And we can call join again. And we have an assertion because the thread is not okay. So we check to see whether it is not joinable, then we throw a CPP error, and if it has been joined already, so we throw then this error, but we on this line, which is a little bit weird and misleading. Might be hard to find the issue, but we printed out a string which is correct. So we have str everything is fine, but what we can do actually, we can check on our own whether the thread is joinable, and we can join it once again, and I can put a breakpoint, but we will not hit it. Yeah, okay, we had the issue when we were testing this code. Yeah, we have it from time to time. So yeah, we can see whether it's joinable, and if it is, we join the thread, and that's correct. So I have 15 more minutes, which is fine. Waiting in exceptional circumstances. Wow, that's really hard word to pronounce, but as mentioned earlier, you need to ensure that you have called either join or detach before the std thread object is destroyed. Okay, and if you're detaching a thread, you can usually call detach immediately after the thread has been started, so this isn't a problem. But if you're intending to wait for a thread, you need to pick carefully the place in the code where you call join. This means that the call to join is liable to be skipped if an exception is thrown after the thread has been started but before the call to join. Okay. Let me read it again, I'm not getting. But if you're intending to wait for a thread, you need to pick carefully the place in the code where you call join. This means that your call to join is liable to be skipped if an exception is thrown. Okay. So if something happened inside this function and we catched an exception, we join the thread and we throw, but otherwise we just join as an AND. Right. Try catch block to ensure that a thread with access to local state is finished before the function exits, whether the function exits normally or by an exception. I don't actually know how do we throw exceptions in C++, but let's see. That's correct. Okay, perfect. Perfect. What was the syntaxes? Ellipsis, right? Yeah, I have to refresh my knowledge of exception handling in C++. let's do this. Some kind of a trickiness. Yeah, that's an assertion, it's not an exception, but okay. Okay, never mind. I don't know, actually, I have to refresh my knowledge how to handle exceptions in C++. It's not that common, and I have never used it, to be honest, but let's continue. So you got the idea. If the function do something on thread, exits abnormally, we catch an exception, we join the thread, and we throw. So yeah, sync. And it's easy to get the scope slightly wrong. So it's so this isn't an ideal scenario. If it's important to ensure that the thread must complete before the function exits, whether because it has a reference to other local variables or for any other reason, then it is important to ensure this is the case for all possible exit paths, whether normal or exceptional, and it's desirable to provide a simple, concise mechanism for doing so. One way of doing this is to use the standard resource acquisition initialization idiom to provide a class that does the join in its destructor as in the following listing. Okay. So what we can do, my thread. What we can do is, let me see. Struct thread protection. We want to define the constructor. We want to have a destructor as well. And we want to have like an a reference to this, to the thread that we are passing, thread. And what else? We have to delete, so we definitely don't want to copy and copy assign, which means that we have to delete operator equals, delete, and we have to remove this as well. What about time? Okay, 53, we have some more minutes. Oops, wrong place. Delete. So we deleted all of those things, and regarding the constructor and destructor, what we can do is std thread, and we initialize this thread, which is fine, and then we check basically whether the thread is joinable. And if it is, we join. In this case, what we have to do is whenever we define the thread, let's assume that some procedure to be executed on a separate thread and we'll hit a breakpoint, and what I want to do is take that procedure, put it inside this thread, and I will specify that like a thread protection and I will put my thread. So whatever this variable goes out of the scope, the destructor will be involved, so that we don't have to call join manually. We just specify the thread protection, and the constructor will call the destructor will do everything for us. It will check to see whether the thread is joinable, and if it is, it join the thread. Otherwise, it will skip to make sure that if you join here somewhere, right? If we join here somewhere, and then when destructor is invoked, we will not execute this if statement. We just skip it. Okay, and we hit a breakpoint, and we are on this thread. We are not on the main one because this thread takes an execution. And to be explicit, I can even set a breakpoint. Yeah, that's fine. When the execution of the current thread reaches the end of f as a function, the local objects are destroyed in the reverse order of a construction. Makes sense? Consequently, the thread guard object G is destroyed first, and the thread is joined with the destructor. Even happens if the function exits because do something in the current thread throws an exception. Destructor first has to see if the std thread object is joinable before calling join. This is important because join can be called only once for a given thread execution, so it would therefore be a mistake to do so if the thread had already been joined. The copy constructor and copy assignment operator are marked as deleted to ensure that they are not automatically provided by the compiler. Copy no assignment such an object would be dangerous because it might then outlive the scope of the thread it was joining. By declaring them as deleted, any attempt to copy the thread will fail because the function was deleted. If you don't need to wait for a thread to finish, you can avoid this exception safety issue by detaching it. It breaks the association of the thread with the std thread object and ensures that std terminate won't be called is destroyed, even though the thread is still running in the background. Okay. Yeah, let's see. Let's read about this section. Con detach on std thread object leaves the thread to run in the background. There's no direct means of communicating with it. It's no longer possible to wait for that thread to complete. If a thread becomes detached, it isn't possible to obtain a std thread object that references it, so it can no longer be joined. Okay, so whatever we call detach, we cannot call join on the same thread. Detached threads truly run in the background. Ownership and control are passed over to the C++ runtime library, which ensures that the resources associated with the thread are correctly reclaimed when the thread exits. Detached threads are often called daemon threads. Okay, 59 minutes. Yeah, let me just finish this. Yeah, okay, we have to make sure that the thread is not joinable. Have 1 minute. Have 1 minute left. My thread, std detach. Std detach. And what we have to do is, okay, we're saying that we have to make sure that, and I will implement this macro in a second, but we have to make sure that my thread is no longer joinable. It's no longer joinable, right? And as I promised, the last line of code that we will implement today, because I want to continue, but I don't want to make this video like 2 hours. It's already an hour. So we check to see if there's an expression, and if it is, then what we do is we cast 0 to the pointer, we assign 0, and we are done. We call the detach and we don't specify anything. Let me copy this procedure right here. We can remove that, and okay. Yes, we hit, and yes, okay. The thread is detached right now. Okay, so that's interesting. So this thread is running currently. Oh, so it was detached, but we don't have like any for loop or anything like that, which is interesting. Okay, so right now it didn't do anything, but if we hit a breakpoint and then we continue, we run in that thread even though it is detached. So we are not on the main thread currently. Yeah. And as you can see in the threads window, we are on the last thread, which is cool, which is okay. But yeah, thank you for watching. I hope it was helpful. I will try to continue a little bit on my own, but no, actually I will not do that. I will try to schedule and try to find time tomorrow and record one more video so we can continue programming, because it's really fun and I want to know more about multi-threading in C++. And further down the line, the author shows how to write data structures, concurrent data structures using threads, which is quite fun. At least I find it joyful. So yeah, thank you for watching.